Hello everyone, welcome to Great Learning. Today we will be learning about hashing in Java. Hashing is a technique by which you will assign a unique code to an object in Java. Also, you will use a hash function that will help you solve many problems while performing operations such as search or delete in a Java program. Hashing is a vital topic when working with classes such as HashMap, HashSet, LinkedHashSet collections in Java. Collections in Java use the hashing technique by maintaining a hash table. So without wasting our time, let's quickly jump to the discussion. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out on any new updates or video releases from Great Learning. If you enjoyed this video, show us some love and like the video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video, any queries or suggestions, and I will respond to your comments. So, this is the agenda for this course. So, first of all, we'll try and introduce you to hashing, and then we'll continue to understand how exactly this hashing works, right? And next, if any collisions occur during your hashing process, how to handle such collisions, right? So what are the different techniques to handle such collisions? Next, we are going to check out the implementation for the hash table, hash map, linked hash map, hash set, and linked hash set. All these are nothing but the collections in Java. So we'll try to implement all these and understand different methods associated with these particular collections in Java. Right? So let's get started then. In this video, let me introduce you to hashing. Okay, so here, what is hashing? Okay, what are the different uses of hashing when you use it in your program or when you're writing your application? Let's check out those in this particular video. All right. So first of all, what is this hashing? Okay, so you can say hashing is nothing but a code. Okay, so say for example, you have your name. Okay, so you have your name, and if you want to convert this name to some code, okay, let me say I'm going to hash your name. Okay, and that hashed name would look something like this. Okay, so 1 a b and some symbol dollar. Okay, so it's not mandatory it should look like this. So it's like you have a name, you're going to apply some method and convert that particular input to a different form, something like this. Now, how hashing will play an important role when you're writing a program using Java. Okay, so in Java you have something called as collections, right? So collection examples are, you have hash map, hash set, linked hash map, linked hash set. Okay, so what are these collections? Collections are nothing but readily available classes with which you can implement your applications. Okay, so those are your collections. Now hashing is nothing but a unique code which will be generated for your values. Okay, you can pass any value, okay, to your program. That value will have an attached hashing code. Okay, with the help of this hashing code, you can perform operations such as search, delete, or insert, or any other operation very easily. Okay, so say for example, if you want to search for a particular value inside your linked list. Okay, so one option is you have to search from beginning till the end, right, in the worst case. Okay, so the time complexity would be O of n, right, until you traverse till the end of your linked list. But here what you can do is you can simply calculate the hash value, and once you get the hash value you can simply store that value there, or simply search for that value with the help of this hash code, right, which will narrow down the your search operation, right? So in such cases hashing will play an important role. That is why it is very important to learn. Fine. So here, as it is written here, hashing is a method to allocate a unique code for any object. Okay, so in your programs you have your objects, right? So all these objects will have its own unique hash code, okay, to identify themselves in the program. Fine, that is your hashing. Now The problem of finding or storing or any other operation in your program will be very shorter with the help of this hashing method, right? So in collections such as HashMap or HashSet or any other collection in Java, if you use this hashing method, all the operations duration will be short. Fine, that is the advantage of this hashing technology. And then you're going to write a hash function or an algorithm through which you can map your data with some integer value in your program. Fine, so that is how a hash code will be generated. Now, one more important thing to note here is every hash code you generate, okay, should be the same every time you run your program. Okay, so any two same objects must return the same hash code every time you run your program. Okay, your function or your hash function should take care of this particular point here. Now, what is the use of this hash code? Okay, so what it will do is it will narrow down the search operation, right? So in a linked list, if you want to search for a particular item, you might get it in the first location, the middle location, in the last location, or anywhere, right? But the problem is in the worst case, you have to traverse till the end. But here, with the help of this hash code, easily you can check for that in a hash table. All the hash codes are stored in a hash table. Okay, so whatever value you want to search, you get access to the hash code. You can directly go to the table and access that particular location using the hash code. Okay, so this will narrow down your search operation and other operations as well. Fine. So I hope with this you have understood the introduction to hashing part. Fine. Thank you. Now we are in our next topic, which is how does hashing work? Okay. So here we'll try to understand how exactly this hashing works. Okay. With an example, I'll try to explain how exactly in the background this hashing works. So hashing, as we know, it's a unique code, right? Now what we do is we try to store the information in the form of a key and value pairs so that we can easily identify the data with the help of this key, right? So it's always a key and a value pair. Okay. Now this key is nothing but the input to our hashing function here. Okay, so we need to apply this hashing function in order to extract the value, right? Every key has associated value. Okay, now this key has to given as an input to the hash function so that we can access the value present at that particular location. Now all this information is stored inside a table called as hash table. Okay, now all this hashing code, okay, the key and the value, everything is stored inside a hash table internally. Okay, now you need not worry about this. All you have to worry about is what is this hashing, how does it work, and what is this hashing function, right? And after that, your hash table should also support the basic functions like, insert, get, that is extract, and deletion operations, right? So in generally these three functions must be supported by your hash table. Now this code, generally it is an integer code. The hash code what we're talking about, it's generally an integer code which is always mapped to the object using your hash function. As simple as that. Now the thing is, how does it work? Okay, so let me take an example. Suppose we want to store list of countries, okay, and their capital cities. Okay, so we want to store this information. So how do we apply hashing to this? Okay, what we can do is we can consider the country names, okay, as key and the capital cities as the values. Okay, so for me, if I have a country name which is a key, then an associated value is nothing but the capital city of that particular country. Okay, now country is the key and the capital city is the value. Fine. So let us try to explore this example more. So consider this table over here. Okay, now here we have countries such as Oman, Italy, Russia, Croatia, and Indonesia, right? And on the values column, we have the capital cities, right? So this position is nothing but the index value. Fine. So internally, what will happen is whatever key you have. So say for example, you have Oman, right? So you have Oman here. So this Oman will have an associated hash code. Okay. And that hash code will make it store at this location 4. Now in this example, to keep it very simple, what I've done is I've considered the count of that particular country name as the index value or the hash code. Okay. So say for example, Oman is 1, 2, 3, 4 letters, right? So it has a length of 4. So what I've done, I've stored it in the index location 4. Okay. And the associated value is nothing but its capital city, which is Muscat. Fine. Similarly, the length of Italy is 5. So I've stored it in the index location 5. Russia is 6. I have stored it in this location. Croatia is 7. I have stored it here. Fine. Similarly, we have the capital cities as the values. So these are your keys. So in this example, based on the length of that country name, I'm locating it in the those positions. Fine. Now we have one more, which is Indonesia, which is 9. We have located it at the index location 9. Fine. Now what is the problem here? Now can you see the positions 1, 2, 3, and 8 are blank? Okay, because as of now we don't have a key value for the position 1 and for 2 and 3 as well. So these are wastage of our memory, right? If we don't have anything to store, suppose if we have allocated so much memory, so this is one thing to consider. Now to understand it in simple terms, we are considering our hashing function as finding out the length of that particular country. In this case it is Oman, right? The first insertion operation, right? So it is 4. We are simply inserting that in the position 4. Now the problem is, what if we have another country of 4 length? Okay. So that time what will happen? A collision can take place, right? So suppose if you have one more country with a length 4, right? So you should design your hashing function in such a way that it should take care of the collision as well. So this was a very simple example for you to understand. Like this, you can design the hashing function in such a way that it should also take care of the collisions which might happen in the future, right? Suppose if I want to insert one more country name, let me take India. Okay, so what is the count of India? 1, 2, 3, 4, 5, right? So if I want to store this, I have to store this at this particular location, right? That is here, right? But we already have one more country there, that is Italy, right? So there is a collision taking place over here. So you should design your hashing function in such a way that it should also take care of collision. Fine. So I hope with this you have understood how exactly hashing works. Okay. And what is this hashing function and how this hashing table looks like. Fine. Thank you. Now we are in our next topic, which is collision handling, right? So it is very important to handle the collisions which might occur in your hash table, right? Because those can cause a lot of problems during your hashing. So let's see how to handle collisions. There are generally two methods for handling the collisions. Let's check out those. So the first one is called as separate chaining. Okay. So how do we handle this collision with the help of this separate chaining? Okay. Now just look at this example over here. That is this table. Okay. So if we have this country, okay. So suppose we have this country Oman. Okay. So this Oman is nothing but our key value. Okay. And the capital city of Oman, which is the Muscat, is nothing but the value, right? So this is our key value pair. in this particular example, right? So if you want to store this information in a hash table, so what we'll do is we'll just count the length of this particular country just as an example, and we'll consider that as the hash code for our indexing. So OMAN is nothing but 4, right? So what we'll do is we'll simply place that in the location where 4 is pointing to, right? So now after this, what we have is we have a country called as Italy, right? So which is a 5 characters, right? ITALY. Okay. Now the capital of Italy is Rome. So that is what is being stored here at the position 5, right? Now the problem occurs when there is one more country with the same length. That is, we have India with the same count. So how do we solve this problem, right? So for that, what we can do is we can use this separate chaining method. Okay. So what this will do is, due to the same index values, okay, we can use this separate chaining method wherein we are going to use the linked list. Okay. With the help of this, we can allocate the values in a chain format. Okay. So look at this particular scenario here. Italy and India both are of length 5, right? So both should ideally be placed here. But what is the solution for that? We are going to link both the key value pairs, right? So Italy, Rome linked to India and Delhi. So this is how you can solve the problem which might occur in your hash table, right? So in this particular example, we are going to solve the problem in this fashion. And then we have another country, that is Russia, which the capital is Moscow. We don't have any problem, right? And similarly with Croatia. Fine. So this is how we are going to solve the collision handling with the help of separate chaining, wherein we are going to use a linked list, right? So next up, we'll try to see one more solution for this collision handling. So there is something called as open addressing. Okay, now what is this open addressing? So let me take an example. All right. So you have these locations. Okay. Suppose you have some value over here and some value over here. Okay. Now, if you want the next value to be placed in this location, okay, but this location is already used by some other value, right? So what is the solution for this? You are going to find out the next available blank location to fill in the next incoming value, right? So this is the solution for handling another type of collision, right? Which is open addressing, because you cannot store two values here, right? So suppose if you want to store one more value such as minus, right? You cannot store it in the same place, right? So you are going to store it in the next available location. Okay. But this solution is not that good as of a separate chain, right? Because here in open addressing, there is a restriction on the usage of storage space, right? You can sometime exhaust your storage limitation, right? So that is the problem with this open addressing collision handling technique. Okay. And some more methods under opening addressing are, you have something called as linear probing and double hashing, right? So if you are going to compare this with separate chaining, this process is slightly slower. Okay. So it all depends on what type of application you are going to use. Okay. So based on that, you are going to decide. If you're okay with the slower process, you can use open addressing. But if you want a smaller or faster operation, then you can go with separate chaining method. Fine. So I hope with this you have understood how to handle collisions in hash table. Thank you. Now we are in our next topic, which is hash table. Now, what is this hash table first of all? So it is nothing but a class which implements hash table, and it is a part of Java collections framework. Okay. So there are a few different things which you should know about hash table, but I think if we implement this hash table in Java, you will get a better understanding of this particular collection. All right. So let's quickly jump to demonstration part. So here we have the implementation for the hash table. So due to the time constraints, what I've done is I have the program for you people here. Don't worry, I'll explain each line so that you'll have a crystal understanding of what exactly this hash table is all about. All right. So first of all, you have to import this hash table class from this library, that is java.utility. All right. And then we will also import one more file from java.utility, which is the iterator, that is to iterate the contents in your hash table. Now we will start our program by declaring a class, giving it a name hash exam1. Then we have our main function. So now the first question is how to create this hash table. Okay, so hash table is a class. Okay, and in the angular brackets we are going to pass the type of hash table. Okay, so if I want to store one integer as the key, okay, and string as the value, I can do that as well. Okay, so it's up to the programmer, he or she wishes to store the key and the value in what type of data. Okay, so in this example I want to store an integer value as a key and string as a value pair. Okay, so hash table is nothing but it's a way to organize your key and value pairs, right? So after that we are going to create an object of type hash table, and on the right hand side we are going to allocate memory, right? So here it's not necessary to pass integer and string. So if you do it on the left hand side, it is understood that you are going to pass the same values here. So then the next question is how to insert the values, right? So once we have defined the hash table, the next step is to insert some values into our hash table, right? So how to do that? We have this method called as put method. Okay, so this put method will help us to insert values into our hash table. So for that what you have to do, simply use this object what you have created of type hash table. So ht dot put 1 comma a. So what is 1 here? It is our key value, key, right? So 1 is nothing but key of type integer, and a is the value which is getting stored with the help of this key 1. Now what happens exactly here is this key what you have here is being converted into a hash code. Okay, so that hash code will help you perform operation quickly, such as the searching operation or delete operation, right? Any operation which you want to perform will be done quickly with the help of this hash code. All right, so that is the reason we have the key value here and we have the value here. Fine. So similarly I'll be inserting some more key and value pairs. So 2 and b, 3 with c, 4 with d. So this is our insertion part, okay, wherein we are inserting these key and value pairs into our hash table. Fine. So after that what we're doing is we are simply printing the contents of our hash table. So for that what you can do is you can simply use this ht, which is of type hash table. Fine. So after doing that we'll try some more methods, right? So we'll try to get the value with the help of the key. Now observe here, with the help of key 1 we are trying to get the value, that is ht dot get 1 will get the value present at the key 1. Okay, and that value is being stored in this variable val. All right, and after that what we're going to do is we are going to simply print whatever is present in the variable val. Fine. So not necessary it should be 1, you can take anything. Let me do it for 3, right? So whatever is present at the value present with this key 3 will be displayed. Fine. Next we'll check out one more method, that is remove method. Okay, so here we are going to remove whatever is present in the value pointed by the key 2. All right, so here what we're going to do, we are going to simply pass the key value. So here I am passing 2. So what is present at the value here, it is nothing but b, right? So what will happen, b will be removed from our hash table. Fine. So that is the job of this remove method. Now after that, we can also use an iterator method. Now this is what we have done here. Okay, observe this. So import java.utility.iterator. So if you want to simply traverse or print the contents of your hash table, fine. So what you are going to do is you are going to take help of this iterator class with one more method called as keyset dot iterator. Fine. So what we are trying to do here is we are trying to iterate through our hash table. All right. So this is the syntax for that, to declare it. And then we are also going to use a while loop, the object which you have created with the help of the iterator class. So itr dot has next, right? So what this has next will do is it is going to check if there is any element present in the next location or not. If yes, it is going to return true. If not, it is going to return false. So while itr dot has next, that is, if there is any element present in the next location, then go inside the while loop and execute all the statements, right? So here what do we have? We have integer dot next, right? So again here we are checking if any element is present. If it is present, then simply return it. Okay, we are storing that in this variable key, and then we are trying to get the value present in that particular key location, right? So ht dot get key, right? So we are starting from the beginning, right? And then we are trying to print whatever key and value pair we have iterated, right? So that is the job of this particular code here. Now what we'll do is we'll simply run this code and check the output and also try to modify the code present over here, right? So let me just save it and let me run it. So can you see the output here? So we have these contents, that is a b c d, right? We have a b c d. So now 1 is equal to a, 1 is mapped to a, 2 is mapped to b, 3 is mapped to c, and 4 is mapped to d, right? So this is what this particular printf statement is doing. And then what we have, what is this c, where has the c come from? So if you see here, we are trying to get the key value here, that is ht dot get 3. We are passing this, storing it in this variable val. Okay, and then we are trying to print whatever is present in this variable val. And what is that? It is nothing but c, which is present at the location pointed by the hash code or the key 3. Fine. Now after that, we are trying to remove whatever value is present at the hash code pointed by this key value 2. So what is present? B, right? So we are simply removing b from our hash table. Fine. So after that, we are using the iterator method and trying to iterate through the hash table. If you see here, we have 4 which is having the value d, we have 3 which is having the value c, and we don't have b here, right? Because we have deleted that particular key and value pair, right? So ht dot remove, we have passed 2, that is, it will delete this particular content from our hash table. As simple as that, right? So finally, when we iterate, we are going to see this particular output with the help of this iterator method. Fine. So I hope with this you have understood how a hash table is declared, what are different methods such as, ht.get, ht.remove, ht.keyset, right? Now let us try to modify our code. Okay, so what I'll do is, let me just try to store null in the place of this particular value. Okay, and let's me save it and try to run it. Okay, so can you see here, we cannot store a null value either in the place of a key or in a null. Okay, so that is the rule of a hash table. Okay, so let me change it. So let me make it d. Okay, and this time let me make null in the place of a key. Okay, so I've saved it. There is no warning here, right? But when I try to run it, I'm going to see an error. That is exception in thread, right? So always remember, we cannot give null value to our key or value. Fine. Now what I'll do is I'll try to duplicate my key. Okay. So what I'll do is let me write E here. Let me write E. Okay. Now look at this here. All the key and value pair. Okay. But the key 4 is repeated, but the values are different, right? We have D and 4 here. We have E and 4 here. Okay. So what could be the possible output? What will our hash table do? So let's check that. Okay. So let me not delete this time. Okay. Let me comment this part. Okay. And let's try to run our program. Fine. So can you see here? 4E, whatever is the latest value present in that repeated key. Okay. So I have 4D, 4E here, but it is displaying 4E, 4E here. That is, it is considering the latest value of that particular key, right? So we cannot store duplicate key values here. Fine. But we can store duplicate values. Okay. So let me show that for you, that to you as well. So this time let me make this 5 and let me make this D. Okay. Let me save it and let me run it. Okay. So can you see here? The values can be repeated, but the keys cannot be repeated. Keys should be unique, right? Because you are going to generate a unique hash code for each of the keys present over there, right? So it is very, very important for your key to be unique. Yes. So what else we have seen? How to print the contents of our hash table, how to get the value with the help of a key, how to delete a particular value pair, key pair. So this time let me delete 5, right? So let me save it and let me run it. Okay. So can you see here? This 5 is deleted once I write the statement, right? But here I'm not deleting it. So if you run it, it is going to print here 1, 2, 3, 4, 5, right? And then I'm going to remove, okay, what? 5. So it is going to print 1, 2, 3, and 4. That's it. It's not going to print the key and value pair 5, right? So these are a few methods of your hash table class, and this is how you are going to declare and use it. Okay. So I hope with this example you have understood how a hash table works, and we cannot store null values either in the place of key or value, and our key should always be unique. Okay. But your values need not be unique, it can be repeated. Fine. So I hope with this you have understood how a hash table works. Thank you. Now we are in our next topic, which is HashMap. Okay. Now what is this HashMap? This HashMap is again a class which is implementing the map interface. All right. So here, whenever you insert the elements inside the HashMap, there is no order maintained, right? So the order in which you insert the elements is not going to be maintained here. Okay. And it can also have one null key, okay, and multiple null values. Okay. So hash map is nothing but a combination of keys and value pair, right? And here you can have one null key but multiple null values, and more than one null key is not valid. Okay. So if you do that, what will happen is whatever is the latest value of that particular key is being considered inside the hash map. All right. So what we'll do is we'll quickly jump to the demonstration part and see how exactly this hash map works. So this is one example for hash map implementation. So starting from the beginning, we have to import this hash map class from the java.utility library. Okay, it is present over there. And once we do that, we have our class hash exam over here. We are starting with our main function, and then how to create or instantiate a hash map class. Okay, so hash map, in this particular example, we have string as our key and integer as our value. It can be anything. Okay, combination of two strings or integers, it's up to you. the programmer, right? So here I want to store the detail of an employee and his or her salary. Okay. So string will be the name and integer will be the salary. Fine. And then this is the way you are going to instantiate your HashMap object. So here I've taken HMap1 as the name. Fine. And then to allocate the memory, we are going to use the new operator. So new HashMap, angular brackets can be left blank. Okay. Because whatever you specify on the left hand side, the same thing will be initialized here. Fine. So the next thing is to add values or add elements to HashMap. Okay. So how to do that? Simple, use the object name HMap1 dot put method. Okay. So this will be the first value to get inside our HashMap. So here John is the key, the name of an employee and the salary associated to John, which is the value. Alright. So through this key we are going to get this value. And this particular element is being converted into hash code. How? Because we are passing keys to all our elements here, right? So that key has to be hashed, right? So that easily you can perform your operations such as search, deletion, insertion, right? So for that reason, we are going to hash it. Now, similarly, we are going to insert 4 such elements into our hash map. Fine. So once we insert, to display the contents of our hash map, we are going to simply use the object name, that is HMap1, inside our print statement. Fine. And after this, we can also print the size of our hash map using the size method, like this. Alright. So here, the size of the hash map is, it is going to print it. Fine. And then if you want to check for a particular key, if that key is present in the hash map or not. So for that you can use this contains key method. Okay, so what we are going to do, if hmap.1.contains key, we are going to pass the key value here, map. Alright, and this, if it returns true, always remember dot contains key will return true or false, a boolean value, right? So if this is true, then we are going to get the value present at MAC. That is, whatever value MAC is pointing to, we can access it using the get method. Fine. So only if this key is present in our hash map, only then it is going to execute. Otherwise, it is not going to execute. Now what we'll do is, we'll quickly run this code, check the output and try to modify our code a little bit. Fine. So let me run it. So can you see here? We have 4 elements here, right? John, Frederick, Mac, Amy. So can you see here? It is not going to maintain the insertion order. Okay. See, first John should have come, then Frederick, then Mac, and then Amy. But can you see here? It is simply inserted in a random way. It is not going to maintain the insertion order. Okay. That is the point you have to remember about the hash map. Fine. And then we are going to print the size of our hash map, which is nothing but 4. And then we are going to search for this particular key MAC if it is present in our hash map. If yes, then we are trying to access the value with the help of that particular key, which is 25,000. That is the salary of MAC. Fine. Now what we'll do is, we'll try to modify our content. So suppose Amy got some promotion, okay, and the salary got increased to 30,000. Okay. So what we'll do is, I'll simply write hmap1, okay, and then dot put, okay. Here, let me use the same key, Amy, and the salary is now upgraded to 30,000. Fine. Or let me make it 36,000. Fine. And then we'll try to print the contents of our hash map. So what should happen now? This Amy, what we have here with the value 27,000 should be updated with the latest value, that is 36,000. Alright. So let's check that whether it is working or not. Can you see here? The latest value is updated to 36,000. The previous salary of Amy was 27,000. Fine. Now, suppose you want to create a new hash map with the same elements present over here. Okay, you need not again use these four steps to insert. Okay, what you can do is you can simply instantiate one more object of type hash map. Okay, so for that, what I'll do is I'll just copy the statement, and here I will write hmap2. Okay, and here I'm going to pass hmap1. All right, so what I've done here, I have to create exact copy of the elements present in hashmap hmap1. Similarly, I'm going to instantiate one more object hmap2 with the same elements present in hmap1. Fine. So let's check that. So let me print hmap2 here. Fine. So let me save it. Let me run it. But before that, let me just type in here system dot out dot println. Okay, so hmap2. Okay, so let's check if we are able to copy the contents or not. Okay, so what is happening here? So it is displaying the previous contents, it is displaying the size, it is displaying our print statement, but it is not displaying the hash map 2 here, what we have over here, right? So what to do? Okay, what is the solution for this? What you can do is you can simply copy these statements, okay, and then instead of doing this, okay, you can leave it blank, and here you can make it like this. Okay, and let me change the values. So let me write Maven, let me write, then let me write Kmo here, and let me write. Fine. So now what should happen ideally? So let me do this. Now if I print hmap2, okay, so let's quickly run and check. Okay, so can you see here? So this is the content of our hmap1 object. The size of hmap1 is 4, and then hmap2 we have these. Fine. So I hope with this you have understood how a hash map has to be instantiated, how to use the methods associated with a hash map, and what are the differences. Fine. Now, one last thing to check is what if I give a null value here? Okay, will it work or not? Fine. So let me just save it and run it. Okay, so can you see here one null value is allowed, that is what it is printing here. Fine. So I hope with this you have understood how a hash map works. Fine. Thank you. Now we are in our next topic, which is linked hash map. Okay, so it's nothing but combination of your linked list and the hash map. So how linked hash map will help you in operations such as searching, deleting, and other methods, right? So let's check those with the help of a demonstration. So here's the code for linked hash map. So what I'll do is I'll explain line by line how linked hash map can be implemented and what are the different methods in regard to the linked hash map. All right. So first of all, we need to import this library, that is java.utility completely. Okay. So because we are using different classes of this java.utility, that is the reason we have put a star here. All right. Or if you want individual, you can do that as well. Now here we have our class LinkedHashMap, and then we have our main method. Fine. And then this is how we are going to create instance of your linked hash map class. All right. So linked hash map, here in the place of key and value, I have string. Okay. It's up to you. If you want integer here, you can make it integer. If you want string, you can make it string. All right. So in this case, I want to store the country names with the capital city. Okay. So wherein both are of type string. So that is the reason I have defined them as string in the angular brackets, and then I've given LHMap as the name for this particular instance. And on the right hand side, I'm going to allocate the memory for my linked hash map. Fine. Now, the most important thing here is how different is this linked hash map from other collections. Okay. So it maintains the order in which you are going to insert the key and value pairs inside the linked hash map. Okay, so for example, if I have inserted Oman Muscat, that will be the first one in your linked hash map. Next, it is going to follow India with Delhi. Okay, so it is going to maintain that insertion order. Okay, we'll see that with the output. Fine. So with the help of put method, I'm going to insert these key and value pairs into my linked hash map. Fine. So after insertion, we will also check out few different methods. Okay. So first of all, we are going to print the contents of our linked hash map. Just simply use this object LH map. Fine. And then we are going to print the size of our map with the help of this method size. And then for any key, you can get the value. Okay, so that can be done with the help of this get method. Okay, so lhmap dot get Oman. Okay, similarly, if you want to get for like Russia, okay, you can do that as well. So let me just change it. Fine. So you can pass any key here, and then I'm going to check, does it have Russia key, yes or not. So dot contains key is the method to check if a key is present in our linked hash map or not. Okay, it is going to return true or false, a boolean value. Fine. So this is your dot contains key method. And then if you want to delete any particular value, okay, so what you can do is you can use the dot remove method as I have typed it here. Okay, so I'm going to print that I have removed this particular element from my map. Okay, that is what this dot remove method will do. And then finally, again, we are going to simply display the contents of our linked hash map. Fine. So let's execute this first and then try to modify and see what are the different things related to a linked hash map. Fine. Let me just save it and then run it. Okay. So can you see here? This is the way I have inserted my values in the linked hash map, right? So first we have Oman Muscat, then India Delhi, right? And then Russia Moscow, and then Japan is equal to Tokyo, right? And the size of our linked hash map is 4. And the value present at the key Russia is Moscow, right? Key are nothing but the hashed code, right? Which can contain some value, because the hashing code will help you for the faster operation for retrieval or deletion or any other operation. And then we are going to delete the element Oman with the value Muscat. Fine. And then we are going to simply delete the latest content of our linked hash map, which is India, Russia, and Japan, because we have deleted the Oman and Muscat key and value pair. So we have deleted that using this dot remove method. Now, this linked hash map can also contain null value in the place of a key. Let us check that. So what I'll do is I'll simply type null, and then let me store Tokyo itself. Let me try this. So LH map. Yes. Fine. Let me save it and let me run it. Fine. So can you see here? It is storing this value Tokyo with the null key. Okay, so one null key is allowed in a linked hash map. Okay, can you see here? Now what I'll do is I'll try to store one more null key. Okay, and let's check what will happen. So what I'll do is this time let me store something like Canberra. All right, and now let's check what will happen. Okay, so can you see here, it ignored the null comma Tokyo pair, and it has considered only the latest null key and value pair, right, which is null is equal to Canberra, null is equal to Canberra. Okay, so it is going to store only one null key. not more than one. Okay, so that is how a linked hash map works, right? So can you see here we have two, right? Now let me store null here as well. Okay, let me do that. Let us check what will happen. Okay, now let's run it. So null is equal to null. Can you see that? And then let me give null here, and this time let me Maldives. Okay, and this will be null. So let's check whether it will store two null values or not. Okay, so we have two null values and one null key. Okay, let's check whether it will work or not. So let me run it. Okay, so let me show you what is happening over here. So can you see here? It is storing null is equal to null. Okay, plus it is storing null as the value. So you can store more than one null value, but you cannot store more than one null key. Only one null key is allowed. That's it, not more than one. So this is how a linked hash map works, and this is how it is different from other collections. It will maintain the insertion order. You can store one null key, not more than one, but you can store more than one null values, right? So here I have stored two null values, right? Can you see here? So this is how your linked hash map works. So I hope with this you have understood all the methods and the instantiation part of a linked hash map. Thank you. Now we are in our next topic, which is HashSet. Okay. Now this HashSet collection implements the set interface. Okay. And here you cannot store the duplicate values, right? Because that depicts your set interface, right? So duplicate values are not allowed in a hash set, right? But the values can be null. Fine. So how does a hash set work and what are different methods of a hash set? Let's try to understand. So this is the code or the implementation of hash set. So we need to import java.utility to make use of this hash set in our program. Now this hash set needs only one argument, that is we are going for string in this particular example, right? Similarly you can store or you can pass integer, string, float, any other data type, right? But in this particular example we are going to use string. This is the instance what we are going to create for a hash set, and on the right hand side we are going to allocate the memory using the new operator, right? So it's not mandatory to write string here as well, right? And then instead of put method, okay, we are going to use the add method to add the elements to our collection, right? So here we are going to use the add method to insert values to a hash set. Fine. So similarly, we are going to insert three values in our hash set, right? How do we do that? Simple. You have created an object of hash set here. So headset dot add a country name, Italy, right? So once you execute this statement, that particular country name will be added to the hash set. Now it's not mandatory that it should follow the order in which you are giving it, right? So set has its own set of rules, right? So here internally hashing is being applied for the values and a hash table is being created to store all the values with the hash code, right? So if you perform any operation such as search, delete or insert, that particular hash code plays an important role. Fine. So it's a combination of hashing and the set properties that gives you your hash set. Fine. And then once I've inserted, we are going to check the contents of our hash set. Now what I'll do is let me add one more content. So headset dot add, let me add one more country. So let me add Maldives. Okay. Let me add Maldives and end it with a semicolon. Fine. Now I've added four countries here, right? And then what I'm going to do is I'm trying to demonstrate the remove method. Okay. So HashSet.remove will find out this particular element, that is Cuba, and try to delete it from our hash set. And then here I'm going to type Cuba, right? So after removing Cuba, what is our latest hash set list? Fine. And then we are going to check using the contains method if this particular country, Italy, is present in our hash set or not. Okay. So it is going to return a Boolean value that is true or false. Fine. And then we are going to iterate through our list, right? So here we are going to iterate over our hash set. So for that, what we have done, we have used the iterator method, HashSet.iterator, while vals dot has next, that is if any element is present, right? It will return true, and once it is true, we are going to print the contents using vals dot next. So again, this next method will check if there is any element present or not. Fine. So first, let me execute this and let's check the output. So can you see here? We have four country names: Cuba, Maldives, Italy, Russia. But the insert order was Italy, Cuba, Russia, and Maldives. Can you see that? It is not going to maintain the insertion order. Fine. And then after removing Cuba, with the help of this remove method, we are seeing Maldives, Italy, and Russia. Fine. And then we are going to check if Italy is present in our hash set or not, in the list or not. So it returned true. That is the Boolean value. Fine. And then we are going to display the contents of our hash set. Fine. Now let us check few more things. Okay. Now what I'll do is I'll try to insert a duplicate value. Okay. Let me insert this Maldives second time. Okay. So let me write here duplicate value. Okay. So let's check if it will print this or not. So I'm running it. Can you see here? It is not going to print that particular duplicate value. Can you see here? Cuba, Maldives, Italy, Russia. That's it. Fine. Now let's insert a null value and check whether it will take or not. Okay. Let me insert null. Let me save it and let me run it. So let me just write a comment. So null value. So if I run it, can you see here? It is considering the null value, fine, but it will not take the duplicate values. Now let me insert one more null value and check whether it will take or not. No warnings. Let's go and check. So can you see here? Only one null value, right? Because set property says no duplicates, right? So this is what it is depicting over here. Fine, let me just delete that. All right. So no duplicate values allowed in a set, but a null value is allowed. That too only one. Now what else? There are different methods on which you can try out your hash set properties. Fine. So hash set plays an important role because here it's a combination of the hashing technology plus the set properties, right? So this plays an important role whenever you are, building an application or writing a Java program using collections, right? So that is why a hash set collection is a very, very important concept. Fine. Similarly, what you can do is you can create one more instance. So let me just copy this. Okay. And let me just write it here. So HashSet 1. Okay. So what I can do is using this, okay, I can insert some more values. HashSet 1 dot add, let me write some country name, USA. Fine. And let me just display that as well. So this will be HashSet 1. Fine. So if I run it, so can you see here USA, right? Now this instance is different and this instance is different. Fine. So remember that this is a different instance what you have created and this is a different one. So in HashSet you have these countries as values and in HashSet 1 you have USA. Fine. So I hope with this you have understood what is a hash set. Okay, how does it work, what are the different properties and methods with which you can explore hash set collection. Fine, thank you. Now we are in our next topic, which is linked hash set. Now what happens in linked hash set? So it's a combination of linked list with the set properties, right? But the most important thing to note here is it will maintain the insertion order. Okay, so unlike hash set, linked hash set will maintain the insert order in which you are going to insert the elements in a linked hash set. Okay, and it will also store a null value. But what about duplicate values, right? Will it store or not? What we'll do is, to try to understand this better, we'll quickly move to the demonstration part and check all the properties of this linked hash set. So this is our implementation part. So here we have this code. Okay, don't worry, I'll explain this line by line. So first of all, we need to import this java.utility.linkedHashSet, right? Because all our collections are present in this java.utility library. Fine. So once you've done that, we can begin our programming with the class. And then we have our main class. All right. So first and foremost thing when we start implementing our main method is we need to instantiate our linked hash set. Fine. So for that, what I've done, linked hash set, I want string data type as my values. Fine. So I'm using that. You can use anything. You can use integer, float, double. Fine. And then I'm going to create an object of type linked hash set. And then using the new method, I'm going to instantiate the memory. Fine. And then what we're doing is we need to insert or add values to our linked hash set. Fine. So for that, what we are doing, we are using the add method, just like the hash set. Fine. Now the major difference here is in hash set it does not maintain the insertion order, right? But here it's a combination of the linked list and the set interface, right? Combination will give you the insertion order method, right? So say for example, if I have inserted in this particular order in my linked hash set, so the same order is being maintained here. Fine, we'll check that. And then first what we are going to do is we are going to print the contents of our linked hash set. Alright. Then can also print the size of our linked hash set with the help of this size method. Okay. And then we can also check if any value is present in our linked hash set or not with the help of this dot contains method. Okay. So here we are checking if CCC is present in our list or not. Similarly, with the help of dot remove method, you can remove any content of your linked hash set. Fine. And then finally, we will also print the latest collection of our linked hash set. Okay. So what I'll do is first let me run this code. Then we will also check out few more properties of our linked hash set. Okay. So let me save it and let me run it. Okay. So can you see here? It is displaying the same contents in which it was inserted AAA, BBB, CCC and DDD. Fine. And the size is 4. And next we are going to check if CCC is present or not with the help of dot contains method. So this will return only the boolean value whether true or not. And then I'm going to remove DDD from my linked hash set. So the latest values present in my linked hash set are AA, BBB and CCC. Triple D was removed with the help of dot remove method. So now what we'll do is we'll try to add same content. Okay. So what I'll do is let me add lset dot add. Okay. Let me add triple A. Okay. And then let me also add a null value. Okay, let's check whether it will take or not. And this comment, let me put it beside this. And here, let me just write add null. All right. So let's see what will happen. So semicolon outside. Yes. So what is happening here? Triple A is being considered only once. That is, no duplicate values are allowed here as well because it is following the set properties. And null is allowed, so it is being stored. And now the size is 5. C is present true. So the latest collection is AAA, BBB, CCC, and null. Okay. So no duplicate values are allowed in LinkedHashSet as well. Okay, because it is following the set properties and it says it will store only unique values, right? So it is not going to store the duplicate values here. Fine. Now the most important thing is whenever you're trying to store such contents or values in your collection, here internally a hash table will be created with hash codes, right? So whatever value you're trying to store, each value has an associated hash code, right? So for operations such as displaying the contents, displaying the size, or checking if any value is present, or delete using the dot remove method, all these operations are quicker because of this hash code and the hash table maintained in the background. Okay, so these play a very important role in our Java collections. Fine. So I hope with this you have understood how this linked hash set works. Okay, let me show you one more thing as well. So this is not mandatory. Okay, this will also work because on the left hand side, if you mention, it is understood that the same value you are going to pass it here. Fine. So let me also show you one more thing. So let me copy that and let me paste it here. Okay. So here I can create one more instance. Okay. With the help of LinkedHashSet class. So here it is going to implement the set interface. Okay. Remember that. Now after this, what I'm going to do is here, let me just write lset2. Okay. Lset2, and here let me add null. Okay, that's fine. Okay, so now let's check what will happen. We should also print the contents, right? So what I'll do is I'll copy this. I'm going to paste it here, but this time it is for the next instance lset2. Okay, let's see what is happening. So can you see here? Linked HashSet contains triple A. Now this is a different instance what you have created, right? And this is different. Okay. So here for the second instance, I'm just going to print the content, which is triple A. Okay. And then let me add this null value as well. Okay. So now if I run it, let me add two null values and check what will happen. Okay. So will it take one null value or two null values? Let's check that. So what is happening? It is considering only one null value. Okay. So I hope with this you have understood what is a linked hash set, how is it different from a hash set. So here the important thing to note is it maintains the insertion order, unlike a hash set. Okay. So with this, let's conclude this linked hash set. Thank you. Let's summarize whatever we have studied so far, right? So we started with introduction to hashing. Here we have understood what is hashing, how will it help you in collections when you're working on Java, and how does it work exactly with an example, right? And then we went on to check few problems which might occur during hashing operation known as collision handling, right? So we have seen two techniques here, that is your open addressing and separate chaining, right? And then we have also seen how to implement hash table, hash map, linked hash map, hash set, and linked hash set, right? So hashing is a very important technique, especially when you're using the collections in Java, right? So whenever you're going to build applications using collections such as hash table, hash map, linked hash map, it will help you a lot in the background, right? Because each object will have a hash code associated with it. right? Which will improve the performance when you're trying to search, remove, that is delete, or insert, right? So whenever you're trying to perform such operations, hashing will help you a lot. So I hope with this you've understood how to use hashing in Java with the help of collections. Thank you. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out on any new updates or video releases from Great Learning. If you enjoyed this video, show us some love and like the video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video, any queries or suggestions, and I will respond to your comments.